Very good. All right, well, I hope you all had a tremendous time at the swimming carnival. I certainly did. What a beautiful day. So, we're into the meat of it. So, chapter 1, you can forget it. No, just that's like what we'll have for the rest of the year. All of those concepts and techniques will be applied in every lesson. So, from now on though, chapter 2, this is what our first test is going to be on, chapter 2. So, you can see at the front there, I've got a checklist. These are the questions we're going to address. Chapter 2 is our first test. It's just rules of calculus. Some you'll be familiar with. There will be quite a few newbies that we learn, and it will take as well the concepts that we've learned a fair bit further. Now, for the first test, you won't have a cheat sheet, so you won't have your own handwritten notes, but you will have the formula sheet on the back. Okay, so this is sort of a formula sheet that we've constructed for you guys to use. You can see a unit circle on there and a number of rules that we're going to learn. So you will have that with you on the test. And the other thing is you won't have a calculator on the first test. Is that what you're going to ask?
No. So is the first test only chapter 2, not 3?
Only chapter 2 for the first test. Very good. Which means our second test is on just chapter 3. Okay? So let's get straight into it. Today we're talking about first principles. So I'll just refresh you on how we derive the formula for first principles. So this is the formula here. And I'll talk about where it comes from. So if we imagine some function of x, all right? And what we want to know is we want to know the instantaneous rate of change. We want to know the slope at one particular point. So if I want to know the slope here at, let's say it's point P, what I could do is find some point M, which is really close to it, and I could find the slope of PM, right? I could find the slope. What is slope? It's a measure of how steep that chord is. Slope is y2 take y1 on x2 take x1. Change in y divided by the change in x. So if I found the slope of PM, it would be reasonably close to the slope at P, right? So this is what we call the instantaneous rate of change, the rate of change at that point. This is an average because it's taken over an interval. So let's say I want to know what's the rate of change at that point. Well, I could say, well, this is pretty close to it, but it's not the same. So one thing we could do is we can move M closer and closer and closer. In fact, we can move it so close so that if you zoom right in on it, here's point P, and it has an x-coordinate x, and here's point M, and it has some x-coordinate of x plus h as h approaches 0. So it's like really, really close. It's like, if this is x plus 0.000000, keep saying 0 1,000 times and then put a 1 on it. They're so close together. Zoomed in up, they're pretty much the same coordinate, right? And so if this is the x value, well, the y value is just the function of the x value. You put the x value in there, that'll give you the y value. And if this is the x value, then the y value is f of x plus h. And what is the slope but y2 take y1, f of x plus h, take f of x, on top of x plus h take x, the x will cancel, so we have the h. That's how we derive the first principles formula, okay? So what does it give rise to? It gives rise to what we call the derivative function. So remember, if we have a function, there's a couple of ways we can denote that. Y equals f of x. And if you put any x value in there, x is 2 or x is 17, it's going to tell you the corresponding y value. When x is 2, the y value is this. When x is 17, the y value is this. What we've derived is the derivative function. We also call it the slope function. And the notation we use for this is dy on dx or f dash of x. All right? Now, if you put an x value into the derivative function, it tells you the instantaneous rate of change, the slope at that point for any value of x. Excellent. Let's get straight into the questions then. So there's the theory. Let's get into it. We've got a bit of process listed there for you. Consider the function. We've got x squared, take 2x plus 4. X squared take 2x plus 4. Find the average rate of change from x is 1 to x is 3. Now the average rate of change, I call it the ARAC, that's the same as the slope. Okay, it means find the steepness between x is 1 and x is 3. So if we want to know the slope, well, we need the corresponding y values. And so we're told between x is 1. So when x is 1, the y value, or f of 1, will be 1 squared, take 2, plus 4. Okay, just putting the x value in there. We'll evaluate that. 1 take 2 is minus 1, plus 4, positive 3. So we've got our first coordinate, right? When x is 1, y is 3. And the next coordinate we're told is x is 3. When x is 3, the function will equal 3 squared, take 2 times 3 plus 4, 9 take 6 plus 4, so that'll be 3 plus 4, 7. Okay, now I've said the average rate of change is the same as the slope. y2 take y1 on x2 take x1. Now, it doesn't matter what we denote as y2 as long as x1 and y1 are together and x2 and y2 are together. That's the second coordinate, this is the first coordinate. Doesn't matter if they were around the opposite way as long as the subscripts are the same. So let's find the average rate of change then at a arc. So it's going to be y2 take y1. 7 take 3 on top of 3 take 1. We'll have 4 on top of 2. We'll have 2. Average rate of change is 2. Between these two coordinates, the slope is 2. Very good. That's part A. Part B. Find the derivative function using first principles. Now, I'll show you a little trick here as well. This is one thing I want you to get in the habit of for year 12. Whenever we have something on top of a number, like if I have sine of x on top of 3, you can think about it like that, but I think a smarter way to think about it is it's 1 or 3 times sine x. Like we can always pull that number out the front. It's much easier for us to write it. We don't have to draw these enormous ampersands, and we don't need to spread it out over the whole page. We can just pull it right out the front. The same with first principles. So we can write this formula like this. Okay, we can just write it as 1 on top of h out the front, and then it becomes much easier for us to deal with. So, let's get into it. The function that we have is x squared take 2x plus 4. Okay, so the function, I might do a little bit of working out here first, so you can see clearly. X squared take 2x plus 4. So that part, that's f of x, that's going to go there for my formula, right? That part is the f of x. I need the f of x plus h. And not a step you need to do, but I'm just going to do it slowly for our first one. For f of x plus h. That means we put x plus h everywhere there's an x. So I'm going to take that x plus h, I'm going to put it there. That would give us x plus h squared. And I take the x plus h and I put it there. So we're going to take away 2 lots of x plus h. And there's no other x plus h's in there. We've just got the plus 4 hanging out at the end. Okay? So that's the f of x plus h. So now we've got everything, right? We've got the f of x plus h component, we've got the f of x component, and we're ready to start the process. So step 1, put it all into the first principles formula. So I'm going to have f dash of x is the limit as h approaches 0 of 1 on h multiplied by f of x plus h take away f of x. Let's use some multicolours here. Okay, so I want you to see how that corresponds with the formula, f of x plus h. We found f of x plus h, it's this whole thing here. This is f of x, so we've set it up perfectly. That's step 1 of your process, always. Step 2, expand it all. Expand everything. So we've got a perfect square here. So in the next step, and now because we've expressed this 1 on h, it's going to compress much more nicely. It will save us a lot of space. So perfect square rule here. I will write it up, and if you're not sure what I'm doing, let me know. A plus b squared expands to a squared plus 2ab plus b squared. Here we're going to distribute that minus 2. And then we have the plus 4 hanging out. Okay, so all I've done there is expand f of x plus h, just completely expanded it. Alright, so that's the first part. Then it's take away f of x. Now you absolutely must put f of x in brackets, because this negative must distribute to all of those terms. So when I distribute this negative, we get negative x squared, we get plus 2x, and we get take away 4. So step 1, put it in the formula. Step 2, completely expand. Okay, so those are written in the process there. Expand, collect like terms. And so the beauty of this is there's a checkpoint. Halfway through your first principles, you know whether you've done it right or not. So what we do, we look along, we're going to collect like terms. Look here, x squared, take x squared. They will cancel. We have minus 2x and plus 2x. They will cancel. And we have plus 4 and minus 4. They will cancel. All right, let's just state what we've got left. Now you absolutely must as well write your limit as h approaches 0 every time until we apply the limit. What have we got left? We've got 2xh plus h squared, take 2h. Okay, here's the checkpoint. Here's how you know you're on the right track. Every term that you're left with must have h in it, because we factorize h and cancel it, right? So, factorize h. So if I'm pulling h out the front, okay, we're left with 2x plus h, take 2. 1 on h times h, that will cancel. And now we can apply the limit, okay? And the limit is effectively, for our purposes, a substitution. I'm substituting h is 0, everywhere there's an h, equals 2x take 2. Very good. So, what have we done here? We found the derivative function. We found f dash of x using first principles. This is our derivative function. This is f dash of x, 2x take 2. Now, first principles is, you'll remember last year we did simple differentiation, a quick way of doing it. You will do that again this year, but first principles is an essential skill. It pops up in about a third of exams. It's quite common. So definitely be something that pops up in our test as well. And they're just beautiful methodical questions, lots of algebra involved, lots of fun. Good, let's move on to part C. Find the instantaneous rate of change as x is 2. So we're going to use that word a fair bit. Instantaneous rate of change. Slope, they mean the same thing. Slope at that point. Instantaneous rate of change, slope at that point. So we found the derivative function, and so we want to know what's the slope when x is 2. We put it into the derivative function. So I'm going to clear some space here, but we'll kick that aside, the AROC aside for now. You guys already have that, so I can write that out. So we saw f dash of x is 2x take 2. And we want to know what's the slope when x is 2? What's the rate of change when x is 2? Well, we're finding f dash of 2. When the x value is 2, we have 2 times 2 take 2, 4 take 2, it will be 2. Alright, good. That's the instantaneous rate of change. Alright, explain the difference between part A and part C. Now, if you look, in part A, we have the AROC is 2. And in part C, we have the f dash of 2, the instantaneous rate of change is also 2. We're asked, what's the difference between them? Okay, so we're going to articulate that clearly. AROC, that's the average rate of change. This is the slope between two coordinates, okay? So let's write that. Part A is the slope between x is 1 and x is 3. Okay, so that's occurring over an interval. Part C is the slope at x is 2. Okay, so that's the key difference. I like to describe it as, I've described it as in the past, you think of you're driving to Adelaide and they have average speed camera safety zones where they'll take a photo of your car at Canalpin and they take a photo of your car at Keith and they say how fast did you travel over that interval. That's your average rate of change, that's how fast you're traveling over that interval. Whereas how fast you're travelling at one instant, well, your speed varies, doesn't it? Sometimes you get up to 110, sometimes you get down to 80 when you're passing through a town. So your instantaneous rate of change can fluctuate, whereas your average rate of change will be constant over that point. Okay, explain the difference, done. Okay, part E, find f of 4 and f dash of 4. So if I'm finding f of 4, that means I'm putting the number 4 into the f of x function. What was our f of x function? We started with x squared take 2x plus 4. So I'll write that up here again. X squared take 2x plus 4. I'm putting the number 4 where the x is. And we'll just evaluate that. 16 take 8 plus 4. 20 take 8, 12. Okay. F dash of 4. Alright, we're putting the number 4 into the derivative function. Okay, explain the difference between them. So, this table, very useful, alright? We put x is 4 in, it tells us the y value. When x is 4, y is 12. We put x is 4 into here, the derivative function. When x is 4, the slope is 6. And so what that means, at the coordinate, x is 4, y is 12. Okay, at x is 4, y is 12. That's the coordinate. The slope, the rate of change at that point, is 6. It has a steepness of 6. It's quite steep at that point. Tremendous work. Okay, so that's first principles. That's what we're familiar with. Okay, that's what we sort of talked about last year. That theory and that sort of formula. So then let's turn to question 2, and let's get you guys. I'll stop here. Let's get you guys to have a go at A. I would expect most of us to be able to have a solid crack at A, and then we'll come back and I'll probably go through B and C together. So I'll stop there. Let's get you guys to have a go at A in your notes books there. We'll just talk quickly about that one, and I want to stress 2 things. If it helps, okay, so just get eyes up here for a moment. Even if you're not finished it, you'll have time to finish that, okay? I just want to say 2 important things. Firstly, do not forget your limits, okay? Make sure you write them in every step. But the second thing is you'll notice, as I'm working this out, I did this expansion over 2 steps. So first I did the perfect square rule, okay, I've expanded it there, and then I've distributed the 2. And I'll do that even as a maths teacher, okay, because that is where it's really easy to make a mistake. It's really easy to make a mistake there. So it's better to do it slowly and methodically rather than stuff up and then have to try and work your way back. Do it slowly, do it properly, and then you get to the right answer. So we perfect square, distribute the 2, and then there's our checkpoint. Once we've collected everything, we're just left with h's, and then applying the limit. Very good. Okay, let's talk about how we're going to do C or B. Which one are we up to? We are up to 2b, the square root of x. So this is where we're going a little bit harder than we went in year 11 methods, okay? In 11 methods, we just did polynomials, right? We just did quadratics and a couple of cubics. So here we have the square root of x, okay? Now, if that's the case, the f of x plus h then will just be the square root of x plus h. Okay, so I'm going to write this out in the formula, all right? What I have is I have the limit as h approaches 0 of f of x, 1 on h, 1 on h times f of x plus h, take f of x. Okay, so I've got the 1 on h out front, I've got f of x plus h, take f of x. And straight away, there's nothing we can do to that. Like, we can't manipulate it in any way. And so what we have to do here is a trick called multiplying it by the conjugate. So I'll talk about what the conjugate is. If we have A take B, okay, the conjugate of A take B will be A plus B. All right? If I had P take Q, the conjugate would be P plus Q. If I had X plus Y, the conjugate would be X take Y. All you're doing is chucking a positive or negative in between. So up here, we're going to multiply this by the conjugate of that. All right, so I'm going to multiply this whole thing by the square root of x plus h, okay? If I have P take Q, it is going to be P plus Q. Now we can't just multiply things willy-nilly, all right? We can't just, let's just times it by 5. And so if we multiply it by that, then we also have to divide it by that. And the reason this is a legitimate operation is because if I have the same thing at the top and the same thing at the bottom, it's that divided by that equals 1. Okay, so I'm just multiplying it by 1. 6 times 1 is still 6. I'm not changing the value of this. So we multiply it by the conjugate. All right? Now, this is useful for us, and I'll demonstrate why to you. If we look, let's collect it all together first, and then I'll show you. So what I have then, I have at the top, I have root x plus h take root x, and that's multiplied by root x plus h plus root x. That's what I have at the top. And at the bottom, we've got h, and the denominator of this whole thing is 1, so h times 1 times that part. So we've got h times the square root of x plus h plus the square root of x. Okay, so we're just collecting the top, that's the top, collecting the bottom, that's the bottom. This is where we do have to have it as a fraction, because we do have a denominator that's not just h. Okay, now, this is where we use one of the square rules we're familiar with, the difference of two squares. If I have a take b times a plus b, it's going to be a squared take b squared. So this is one we start learning early. This is the difference of two squares. All right, and look at this. X plus h take root x times root x plus h plus root x. This is the difference of two squares. And we've set it up such that we can use that. Of course, we expect to use that. So this is going to simplify them. We leave the denominator, never mess with the denominator. The denominator will always work itself out in the end. So the denominator can stay the same. And at the top, I've got a take b times a plus b. Well, it goes to a squared. So that means it's going to be x plus h squared. Okay, the square root of it squared, it just becomes x plus h at the top. All right, I'll just stress that part. If I have root x plus h squared, well, the squared and the square root just cancel. I'm left with x plus h. Okay, so that's what the first term becomes. And then the second term is just root x squared, which is just x. Okay, now if you don't believe me, feel free, go ahead, do your FOIL. If you FOIL all that and work that all out, this is what you're going to get anyway. We're just skipping that using the difference of two squares. So at the top, I've got x take x, they will cancel. I'm left with h on top of h times root x plus h plus root x. H is at the top and the bottom, so it can cancel. Okay, so we're cancelling our h. What are we left with? 1 is at the top. Remember, it doesn't just disappear, it doesn't become 0. And at the bottom, we have root x plus h plus root x. Now we'll apply our limit. Okay, so if I apply the limit, that means h goes to 0. So what I've effectively got is 1 on root x plus root x. And if I have one lot of root x, plus another lot of root x, that means I've got 2 lots of root x as the denominator. That is our answer for part B. Okay. All right, we might pause there, get you guys to do a few, and then we'll come back for the very last one, 3 on x squared, or we might even do 3 on x. We'll see how we go, because that's quite a nice long one as well. So with the textbook, we'll start with the textbook work. Once you've got that example down, we won't do question 2 for now. Okay? We might even just do, we'll do a couple. I'm going to just write on the board what ones I want you to do first. Okay? So let's start there. All right, so I'll just say quickly as well, look, even if you're, like one strategy we've used in the past, this will be important, Jack and Harry, is you can watch what I do, all right, and then have a go at it yourself, okay? Because then you've sort of witnessed how I've done it, and then rather than copying and you sort of half listening and you're trying to copy it down, you're rushing to copy it down, it can be a good strategy to just watch and then try that same question yourself while it's fresh in your mind, because that's for that zone of proximal development, right? That's when you're wrestling, when you're really wrestling with the question yourself. So let's talk about this one here. This is the function we've got. This is f of x plus h. All I've done so far is set it up in the formula. 1 on h, f of x plus h, take f of x. Now, let's just pause at that line, and let's come over here and talk about how we add and subtract fractions. If I'm going to perform this operation, they need to have the same denominator. I can't subtract it unless they have the same denominator. So that's what we need to do. We need to make them have the same denominator by cross-multiplying the denominator. So if I multiply this one by 3 on 3, okay, I'm taking that denominator, 3 divided by 3 is 1. I'm not changing its value, I'm just changing the way it looks. This would become 9 on top of 12, okay? And if I multiply this one by that denominator, 4 on 4, it would become 4 on top of 12. Now they have the same denominator. Now we can perform that operation. So we would bring them together, it's 9 take 4, all on top of 12, and you can see that would be 5 on top of 12. That's what it simplifies to. Now that there, hopefully we're pretty comfortable doing that with numbers. That's what we're doing with x's over here. So if I'm going to subtract this, I need them to have the same denominator. They don't have the same denominator, so I'm going to cross multiply the denominators. So I'm taking that x squared, okay, and I'm multiplying this one by x squared on x squared. Okay, I'm taking it from there, x squared on x squared. And then if I want this to have the same denominator, I'm taking that x plus h and putting it there, x plus h on x plus h squared. Okay, so we're just cross multiplying the denominators. And then in this step, all I've done is shown what happens when I multiply it. So this term becomes 3x squared on x squared times x plus h squared. This term becomes 3x plus h squared on top of x squared times x plus h squared. And then because they're the same denominator, because they're the same, you can collect them. So I'm just breaking it down, doing it in a number of steps. I've collected them here. All right, so all of that is to say, we put it in the formula and we've made it have the same denominator. That's all we've done so far. Now we're ready to just do what we do with first principles. Expand it, collect like terms, and apply the limit. Okay, so if I'm going to expand this, again I've said do it in 2 steps, right? Because we have the 1 on h out the front, we have 3x squared, x squared plus 2xh plus h squared. Okay, that's what we've got at the top. Don't expand the denominator, it will work itself out. We'll just leave it there for now, x squared times x plus h squared. Okay, so all I did in moving from here to here is perfect square that. In the next step, I'm going to distribute this 3, this negative 3, okay? So I'll do that here. We have 3x squared, take 3x squared, take 6xh, take 3h squared. Alright, so put it in the formula, make them have the same denominator, expand, now we can collect. Look, 3x squared, take 3x squared, that will cancel. What am I left with? At the top, I've got minus 6xh, take 3h squared. At the bottom, x squared times x plus h squared. Don't forget your limit. Okay, factorise h, as we've done. Limit as h approaches 0, 1 on h, factorise h, minus 6x, take 3h. I said leave the denominator. Okay, that will cancel. Let's apply the limit. This part 0, alright, so I've got minus 6x at the top. At the bottom, I've got x squared. And then this, if that's 0, I've got x squared times x squared. Okay, so we can simplify that a little bit. Minus 6x on x to the 4. We've got x at the top and the bottom. Minus 6 on x to the 3. So that's a massive tricky one, right? And you will see ones like that. So just to take you through, the part where people probably get stuck is making them have that common denominator. But it looks beautiful, right? You know, what a piece of art. So, all right, so, yeah.
Does it look beautiful?
Yeah, it's objectively beautiful. So let's get you guys to have a crack at that one. I'll leave it up here and I'm happy to prompt you throughout it. But yeah, you guys have a crack at that and then you're ready to tackle the rest of the exercise.